Question 1. Nathan and Lucy make and sell wooden items for gardens. Part A. Nathan makes and sells benches, tables and tool sheds. Last year, the profit he made from selling these items was in the following ratio. So benches to tables to tool sheds, 2 to 3 to 7. What fraction of his profit did Nathan make from selling benches and tables? So we're going to need to write each part of this ratio that relates to benches and tables as a fraction of the total number of parts of the ratio. So the total number of parts, 2 plus 3 plus 7, 2 plus 3 plus 7 is 12. So we're interested in benches and tables. So benches are 2 out of those 12, so that's 2 over 12. And tables are 3 out of 12, so that's 3 over 12. We want the fraction of profit he makes selling benches and tables. So doing 2 over 12, add 3 over 12. If you're not comfortable with fractions, then enter it into your calculator. So 2 over 12, remember to arrow off before you press add. 3 over 12, that gives an answer as 5 over 12. If you are okay with fractions, you will have known that the denominators are the same, so we simply add the numerators. So 5/12 is our fraction of profit for selling benches and tables. Part 2. His total profit was £18,072. How much profit did Nathan make from the sale of tool sheds? Okay, so the sale of tool sheds is 7 12s. So 7 of those 12's total parts. So if we multiply this by the total profit, that will tell us how much he made from tool sheds. So 7 over 12, arrow off your fraction again, multiplied by 18,072 is equal to £10,542. So that's how much profit he made from the sale of tool sheds. Part B. Lucy makes and sells planters. Each planter costs Lucy £32 to make. Each one that she sells make a profit of £80. What is Lucy's profit from the sale of one planter as a percentage of the cost to make the planter? So the profit of the sale of one planter is 80. The cost to make the planter was 32. And we want it as a percentage, so we're going to multiply this by 100. So 80 divided by 32. Remembering to arrow off your fraction. I'm just trying to make it so you can see my calculator. It's not very bright. Arrow off the fraction and then multiply by 100 to turn that fraction into a percentage. So that's 250%. It's okay that it's 250%. We can have percentages that are bigger than 100. Question 2. The table gives a summary of the masses, m grams of 30 buzzards. So this is our table. So we have the masses and we have these classes, these ranges of values and our frequencies. Part A. Moeen uses the midpoint of each group to calculate an estimate of the mean mass of the buzzards. He does this correctly. Calculate Moeen's answer. So we're using the midpoint, and that's the midpoint of these two values here. So if you can't spot the midpoint, if you add the starting point 600 plus the end point 700 together and then divide by 2, that tells you that the midpoint is 650. And you can do that for each of those if you need to, if you can't spot what the midpoint is. Okay, so now to estimate the mean, we're going to do the midpoint multiplied by the frequency as our first step. So we're going to do 650 multiplied by 8, 750 multiplied by 7, 850 multiplied by 4, 950 multiplied by 11. So we're going to do those sums to start off with on our calculator because it's a calculator paper. Being careful what we enter into our calculator. We've seen in my previous videos that it's easy to make mistakes, so it's worthwhile being super careful. Okay, so to estimate the mean, we're going to total these together. So and then we're going to divide this total by the total number of buzzards. So 24,300 divided by 30. Remember, leaving things in our calculator makes life a little bit easier, so we don't have to enter digits in and potentially make some errors. So I get an estimate of the mean mass of the buzzards as 810, and we're working in grams, so I'm going to pop grams there next to my answer. Part B. Dita decides to estimate the mean mass of these buzzards. She uses the values 600, 700, 800 and 900 rather than the midpoints. Explain why her method is unlikely to give a good estimate of the mean mass. So what Dita's done here is use the lowest possible value that it could be within each of these ranges, within each of these classes. So actually her answer is going to be an underestimate. She's using the lowest value, so the mean's going to be too small. So I'm going to say that she's using the lowest values, so the mean will be too small. Question 3. Debbie collects data about a group of 20 people. Her data is the total number of years for which they have owned a pet and the number of visits they have each made to their doctor in the last year. The scatter graph shows her results and her attempt to draw a line of best fit for the data. So this is her scatter graph, and that straight line is her line of best fit attempt. Part A, make a criticism of Debbie's line of best fit. So a line of best fit, the aim of it is to give us an average that follows the trend of the data that we could potentially predict from if we need to. Now, the line follows the trend of the data in terms of it's following the same direction. It looks like it's got a negative correlation. However, there are no points above the line. And when we're doing a line of best fit, if we're wanting an average to estimate from, we need to be roughly in the middle of all the points. So we'd expect points to be on either side of that line. So what I'm going to say here, my criticism is there should be points above and below the line of best fit. Okay, part B. Debbie says, because there's a negative correlation, owning a pet for longer causes people to need to visit the doctor less often. Is Debbie correct? Yes or no? Explain how you decide. This is important. Don't just tick a box yes or no yet. We've got to explain how we decide, guys. All right? So, yeah, there's a negative correlation according to this line of best fit and the direction that the data's going in. However, correlation doesn't imply causation. There is absolutely no relationship between whether you own a pet and how many times you visit the doctors. There's no relationship between that whatsoever. So we can say, we can simply write correlation does not imply causation, or there is no relationship between them, it's just a coincidence. So I'm going to put that. There is no relationship between them. It is just a coincidence. And then I'm going to say Debbie is not correct because there isn't a relationship. How many pets you own have no bearing on how many times you might visit the doctor. Question 4. Janet invests £5,000 in a savings account for 9 years. She makes no further payments into or out of the account at this time. So that £5,000 is the only money that goes in and none of it comes out. For the first 5 years, her investment earns 2% compound interest per year. After this, the interest rate decreases to 1.3% compound interest per year. How much is Janet's investment worth at the end of the 9 years? So we've got 2 stages to this, guys. We've got the first 5 years and then the rest of the years. So we start by investing £5,000, and for the first 5 years, so I'm going to put that here. So the first 5 years, it's 2% compound interest. So we want 100% of the amount plus 2% interest, which is 102%. I'm going to convert that to be a decimal by dividing by 100. So 102 divided by 100. On a calculator, if you're not sure, guys, is 1.02. So 1.02 is my decimal multiplier that I'm going to use, but that's just for the first 5 years. So I'm going to raise that to the power of 5. Okay, this whole investment is for 9 years. We've dealt with the first 5 years, so we've got to consider the next 4 years. So the next 4 years have a compound interest rate of 1.3%. So it would be 100% of the amount plus 1.3%, which is 101.3%. I again want this to be a decimal multiplier, so 101.3 divided by 100 is 1.013. So that is my decimal multiplier for the next 4 years. So I'm going to raise that to the power of 4. I'm just going to pop this all into my calculator now as carefully as I can. So 5,000 multiplied by 1.02 to the power of 5, remembering to arrow off from the power before I then start typing the rest of the sum. So then we've got 1.013 to the power of 4, and then I'm going to press equals. So this is 5,813.111385. We're working with money, guys, so we want to work to 2 decimal places. So that would be £5,813.11. Let's check what the question's asking us for. How much is Janet's investment worth at the end of the 9 years? Well, this is how much the investment is worth. That's what will be in the account at the end of the 9 years. 5A, circle the correct conversion of 7 meters cubed to centimeters cubed. Okay, so if we were going from meters to centimeters, we would multiply by 100. Here we're going from meters cubed to centimeters cubed, so we need to multiply by 100 cubed. That's the important thing here. So 7 meters cubed equals 7 times 100 cubed. So stick that in your calculator. 7 times 100 cubed, which is 7 million. Guys, so make sure you circle the correct number. When they're multiple choice, don't just guess. Do some working out. 5B. The diagram shows a shape made from a trapezium and a circle. So we have a trapezium and then we have the circle. The parallel sides of the trapezium are tangents to the circle. So these 2 sides that are parallel are also tangents to the circle. So this tells us that they touch the circle at a point, but they don't cut through the circle. The diameter of the circle is 30 centimetres. The ratio of the white area to the shaded area is as follows. So the white area to the shaded area is 1 to k. Find the value of k, show all your working, and give your answer correct to one significant figure. Okay, so the first thing I'm going to recognise here is that we're working with area. Okay, so I'm going to start by finding the area of the trapezium and the area of the circle. So for the trapezium, to find the area, you add the 2 parallel sides together, so 62 and 79. So 62 plus 79. Then we multiply that value by the height, the distance between those 2 sides. So 141 multiplied by 30. And then we half that value to get our area. So the area of the trapezium is 2,115 centimetres squared. I'm now going to find the area of the circle. So we're doing pi times radius squared. Well, the diameter we're told in the question is 30, so the radius is half of that, which is 15. Remember, you can do 30 divided by 2 on your calculator. So the circle has an area of pi times the radius squared, which is 15 squared. So pi times 15 squared is 225 pi centimetres squared. I'm going to leave it in terms of pi so I don't have lots of decimals to enter into my calculator. So we're working with area. I found the area of the trapezium and I found the area of the circle. The next thing we need to deal with is that our ratio works in terms of the white area, which is the circle, and the shaded area. So we need to find out what the shaded area is. To do that, we're going to take the area of the circle away from the area of the trapezium. So here we're working with the shaded area. So the area of the trapezium, take away the area of the circle. So 2115, subtract my answer that was left in my calculator. Okay, so that is the area of the shaded region. So now we're going to go back to this ratio. So we've got the white area and the shaded area. So the white area is 1, the shaded area is k. Now we've said our white area is the area of our circle. So I'm going to pop that in there. So that's 225 pi. Our shaded area is this here. So that's 1408.141653. We need to find what k is. So we need to scale this ratio down to get to 1. So what we would do to make this part of the ratio 1 is divide by 225 pi. So I'm going to do the same on the other side. So my answer's still in my calculator, so I'm just going to divide by 225 pi. So that tells me it's 1.992119293. Now it asks us to give our answer correct to one significant figure. So that's 1 to the ratio of one significant figure here, guys. So the 1 in the units or the ones column is our first significant figure. The 9 next to it is 5 or above, so that's going to move up to 2. The question asks us to find the value of k. This side of the ratio is k, so k is equal to 2 to one significant figure. Question 6a, solve 5x, add 4 equals 2x, add 6. So we know that I like space to do this. So I'm going to carefully write my equation here just to make sure I don't write anything incorrectly. So we're solving for x, the unknown variable. X appears on both sides of this equation. So the first thing I need to do is eliminate the smallest x term. So we have positive 5x and positive 2x. I know that they're both positive because there's no negative sign in front of them. 2x is smaller than 5x. So that is the smallest x term. That's the term that I'm going to eliminate. So the opposite of having a positive 2x there, the way I'm going to eliminate it is by taking 2x away from both sides. So when I take 2x from the left-hand side, 5x take away 2x is 3x. My plus 4 is still there. I've done nothing with it. It's not an x term, so it's staying where it is. I need to do the same to the right-hand side to balance the equation. 2x take away 2x is 0. We've eliminated that 2x. We're just left with 6 on the right-hand side. Now we've got a two-step equation. To solve for x, I need to isolate the x term. So I'm going to eliminate the add 4 from the left-hand side. The inverse of adding 4 is to subtract 4. So when I subtract 4 from the left-hand side, that cancels out the positive 4 and leaves me with 3x. I have to do the same to the right-hand side to balance the equation. 6 subtract 4 is 2. Now I've got a one-step equation, 3x equals 2. 3x is 3 multiplied by x. The opposite of multiplying by 3 is dividing by 3. 3x divided by 3 gives me x, so that's my x term isolated. I have to do the same to the right-hand side. 2 divided by 3. I'm going to write that as a fraction, guys, 2 divided by 3. If you're not sure what that looks like as a fraction, put 2 divided by 3 in your calculator. Let your calculator show you. I'm going to leave it written as a fraction as my final answer because it doesn't tell me it wants it in any other form. Part B. Solve. 4x subtract 3 is greater than 17. So 4x subtract 3 is greater than 17. I'm going to solve this exactly as I did here, but instead of an equal sign, I'm going to write my greater than symbol. It's important that I keep the symbol the same. So the first thing I'm going to do here is I'm going to eliminate the subtract 3 on the left hand side because I'm aiming to isolate the x term. The inverse of subtracting 3 is to add 3. 4x, add 3 eliminates the minus 3 is greater than, and then I need to do the same on the right hand side. So 17 add 3 is 20. Again, don't forget, you can do that on your calculator to save your brain power. Now we've got a one-step equation. 4x is greater than 20. 4x is 4 multiplied by x. The inverse of multiplying by 4 is to divide by 4. So when I divide by 4 on the left hand side, 4x divided by 4 gives me x, which isolates the x. We've still got the greater than symbol, and I need to divide by 4 on the right hand side as well. 20 divided by 4 is 5. 20 divided by 4, you can do that on your calculator to save your brain power. This whole thing now, guys, is my answer. So if there was an answer line, I'd have to write this whole thing with the correct symbol on there to get the marks. Part C. Solve the following simultaneous equations. Use an algebraic, not graphical method. You must show all you're working out. Okay, so when I'm solving simultaneous equations, I'm looking for an x and a y value that works for both equations. The first thing I need to check are the coefficients of the terms. So if I look at the x terms, I've got 5x and 1x. So a coefficient of 5 and a coefficient of 1, they don't match. I'm looking to have terms that have the same coefficient. Let's look at the y terms. Minus 2y, minus 1y. So this is minus 2 coefficient, this is minus 1. They don't match. So now I need to make the coefficients of either the x or the y terms match. I'm going to make the coefficients of the y terms match. I'm going to multiply this equation by 2. When I multiply this equation by 2, everything gets multiplied by 2. So x times 2 is 2x, minus y times 2 is minus 2y, and 5 times 2 is 10. I'm now going to write this equation above it. I'm not going to change this equation in any way, because what you will see here now, guys, is that my y terms both have a coefficient of 2. It doesn't matter what the signs are in front of them, it's the number that's important at this point. They both have a coefficient of 2. So that means I'm now going to eliminate my y terms so I can solve for x. So I need to do a sum here. I'm either going to add or subtract. What signs I have here makes me make that decision, okay? So if the signs are the same, we need to subtract. So I've got 2 negatives, we need to subtract. That's why I always change these terms here, because these signs are very helpful. If the signs were different, I'd have to add. So we're going to subtract these equations now. 5x subtract 2x leaves me with 3x. Minus 2y subtract minus 2y eliminates the y variables. 16 subtract 10 equals 6. Now I've got a one-step equation that I can solve for x. I've eliminated that y variable. So 3 times x equals 6. The inverse of multiplying by 3 is to divide by 3. 3x divided by 3 gives me x and isolates x for me. Do the same on the right hand side to balance the equation. 6 divided by 3 is 2. There's no separate answer line here for my x and my y value, so I'm going to highlight that my x value is 2. Okay, final step. We need to find out our y value, so I've got to substitute this x value into one of these two equations. I'm going to use this equation here, so x minus y equals 5, but when x equals 2, that becomes 2 minus y equals 5. I'm aiming to solve this equation for y now, so I need to isolate the y term. So I'm going to eliminate this positive 2. I know it's a positive 2 because there's no negative sign in front of it. So the way I'm going to eliminate a positive 2 is to subtract 2, which leaves me with minus y on the left hand side. But when I do the same to the right hand side to balance the equation, 5 subtract 2 is 3. Now the important thing to notice here, guys, is we've got a negative y. That negative sign stays with the y. I don't want a negative y, I want a positive y. This is technically negative 1y. So that's negative 1 multiplied by y. So if I divide by negative 1, negative 1y divided by negative 1 gives me positive y. But I have to divide by negative 1 on the other side. So 3 divided by negative 1 is negative 3. If you're not sure about your negatives, do 3 divided by negative 1 on your calculator just to double check. So that's our y value, y equals negative 3. We can double check this if we want to by substituting both of those values into an equation and checking that we get that correct answer. Question 7. So we have a diagram at the top here, not drawn to scale, so we can't measure anything directly from it. So the question tells us the diagram shows a rhombus ABCD, ABCD. So this is a rhombus. And the first thing I'm going to do is I'm going to mark that all these 4 sides are the same, because that's a property of a rhombus and that might come in handy. All 4 sides are the same. AC and BD intersect at E. So the line from A to C and the line from B to D intersect here at E. The length of AC is 12 centimetres. So this line AC has a length of 12 centimetres. Angle BCE is 35 degrees. So BCE, that angle there is 35 degrees. The question asks us to find the perimeter of ABCD. So we want the perimeter of the rhombus. Now the important thing here is that all 4 sides of that rhombus are the same. And to find the perimeter, we would add all the sides up of the shape to get the total distance around the outside of it. So actually we only need to find one of those sides and then we can multiply it by 4 because they're all the same. So what I'm going to do here, guys, is I'm going to just deal with one side of the rhombus, and you can see that pink triangle that I formed there, because AC and BD intersect at a perpendicular point and that forms a right angle. So if I look at this triangle here, the pink triangle, I'm working with a right angle triangle, which is going to be handy because there's many things I can do with a right angle triangle. Now I'm just sketching it here just to take it away from the main diagram and make it nice and clear. So that's a right angle. This angle is 35 degrees, and I know this length because EC is half of AC, so half of 12, so that length is 6 centimetres. Now I'm trying to find the side here, guys, of the rhombus. So I'm trying to find that side of the triangle. So we have a right angle triangle. We know another angle, so we're dealing with trigonometry here, guys. So the first thing I'm going to do is I'm going to label my sides. So opposite the right angle is always the hypotenuse. Opposite the other angle is always the opposite, which means the remaining side is adjacent to that angle that we know. So we're going to highlight what sides we have information for. So I know that the adjacent is 6 centimetres and I'm interested in the hypotenuse because that's the length I want to find. I'm not interested in this side at all. So I'm dealing with the adjacent and the hypotenuse. So we're going to use SOHCAHTOA, and I know that the adjacent and the hypotenuse relate to the cosine function. So you might remember this formula triangle if you've used them before. So the cosine function is the adjacent over the hypotenuse. So all I'm going to do with this formula here is substitute in what I know. So the angle that we're given goes with the cosine function. The adjacent is 6. And the h is what we're looking for, which is x. Now, if you're comfortable with algebra and rearranging this equation to solve for x, go for it, you can do that. Otherwise, you can use this formula triangle to help you. So we're looking for the hypotenuse. So if I cover the hypotenuse, it tells me that to find x, I need to do the adjacent side divided by cosine. So to find x, it's the adjacent side of 6 divided by cosine of the angle 35. And I'm going to pop that into my calculator, guys, and that'll tell me the length of x. I'm going to put it in as a fraction. I'm going to close my bracket that automatically opens with the cosine function. So that tells me x is 7.324647533 centimetres. So remember, that's one side of my rhombus, and I'm interested in finding the perimeter. So I have 4 of the same sides. So the perimeter is equal to 4 times the 7.32, etc. I've kept that in my calculator, so I'm just going to simply multiply that by 4, which is 29.29859013 centimetres. Now the question doesn't ask us to round it in any way, so I'm just going to round it to 1 decimal place. I'm going to write 29.3 centimetres there for my final answer. Question 8. The table shows some of the values of h equals -3 multiplied by t add 1 in a bracket and t subtract 4 in a bracket for a range of values of t from 0 to 5. So this is our table of t values are from 0 to 5. This is our function, and some of the values have been filled in. Part A, complete the table above. So to complete the table, we're simply going to substitute in the t values to find the appropriate h value. So I'm going to leave it like this. I'm not going to expand it, guys. So when t equals 0, h equals -3, 0 plus 1, I'm replacing that t with a 0, and then 0 subtract 4. I'm going to put it in my calculator just like that, guys. No messing around. So don't forget the minus at the front. 0 plus 1, 0 subtract 4. So that gives us a value of 12. So we're going to put a h value of 12 there. I'm going to do the same when t equals 3. So we have h equals -3. 3 plus 1, because we're replacing the t with 3. 3 subtract 4. And I'm going to do that in my calculator again. But rather than enter it all in, I'm going to go back. And wherever there was a 0, I'm going to enter 3 because my t value is now 3. That also gives me a value of 12. There we go. And then the same for when t equals 5. So h is -3. This time t is 5. I'm going to go back, and the 3's, only the 3's inside the bracket, remember that -3 on the outside isn't a t value, gets changed to 5. So that gives me -18. So that's part A. Part B, on the graph below, draw the graph of h equals -3 multiplied by t add 1 and t subtract 4 for these values. So we're basically plotting these coordinates because that function, that equation, matches exactly. So we're going to plot those values. So these are our coordinates. So we're going along to t and then up or down to the corresponding height. So when t is 0, we're going up to 12. So t is 0, we're going up to 12. Be careful with the scale, guys. So from 10 to 15 is 10 little squares. So 2 squares is equal to 1. So that's 11. That is 12 there. So that's my first point. Then I'm going to go t is 1 and up to 18. So t is 1, 15, 16, 17, 18. T is 2 up to 18. T is 3 up to 12. 11, 12. T is 4. H is 0. And then t is 5, and we're going to -18. So that's -15, 16, 17, -18. So we're going to sketch the curve. Now what you need to do is sketch this in pencil, guys, just in case you make a mistake. It is a curve, so we don't want any straight lines, but it doesn't have to be perfect. It just, oh, snap my pencil, just has to, as best as you can freehand, go through those points accordingly. So that's part B. Part C, Derek throws a ball upwards from a point above horizontal ground. So this is the image that you can see here. The height h meters of the ball above the ground t seconds after Derek throws it, so h meters t seconds after he throws it, is modelled by that equation. So the equation that we were working with in part A and B. What is the height of the ball above the ground at the start of Derek's throw? So at the start is important because that's when the time is 0. Okay, so we want to work out h, the height, when t is 0. Okay, so you can substitute it in, or you can go back to your part A. We already worked out what it was when t equals 0. It equals 12. So I'm just going to copy that onto this question again. So h equals -3, 0 plus 1, 0 subtract 4 equals 12. So the height at t equals 0 is 12 meters. Part 2, how many seconds after Derek throws the ball does it first hit the ground? Again, we're going to look back at our table because if it hits the ground, we've got a height of 0, haven't we? So let's have a look. T equals 0 is when Derek's starting. This is 1 second later, 2 seconds later, 3 seconds, 4 seconds, and 5 seconds after throwing it. Okay, so we want to know when the ball first hits the ground. So when it's got a height of 0. So let's have a look. H equals 0. Well, that was t equals 4. So we can say that it was 4 seconds that after he throws the ball that it first hits the ground. Part 3. How many seconds after Derek throws the ball is it at its maximum height? Okay, so this is where we're going to have to go back to our graph because it's a curve and the highest values we can see are at t equals 1 second and t equals 2 seconds, but something will have potentially happened here and we can see it did on our graph there. So what we're going to do is we're going to read down roughly where its highest point would be, and actually it's its line of symmetry, guys. So it's going to be halfway between 1 and 2. All right, so that's when the graph starts, the curve starts to come back on itself. So 12, 18, 18, 12. So this is the line of symmetry. So it's halfway between 1 and 2. So that must be 1.5 seconds. And then part 4, what is the maximum height of the ball above the ground? Okay, so the maximum height of the ball above the ground. So we're going to use our graph to read this off. However, we've roughly drawn the curve. Okay, so this is going to be an estimate, but where we hit our maximum point when t equals 1.5, we're going to read across to that other scale here, and then we're going to read off roughly what we think the maximum height is. So remember, each of the 2 of these squares is 1, so that's 16, 17, 18, 19. So it's roughly 19 meters maximum height, and that one is a range of values that you can have, guys, because everyone might draw this part of their curve slightly different. Question 9. The diagram shows the interior length, width and height of a wooden crate. So this is our wooden crate. The diagram's not drawn to scale, so we can't measure anything directly from it. So Jake fills the crate with solid beeswax cylinders. They each have a length of 32 centimetres. The cylinders fit tightly in the crate with 8 cylinders in each row. The first 2 rows are shown in the diagram. So you've got 8 cylinders, so they fit across here, and they've got that length of 32 centimetres. Jake continues to fill the crate in this way. The density of the beeswax is 0.961 grams per centimetre cubed. Jake calculates the total mass of the cylinders to be more than 70 kilograms. Is he correct? Yes or no? Show how you decide. Okay, so we're working with density and mass, so that means we're also going to be working with volume. So density is mass divided by volume is going to be important to us here. So all of the mention is around those solid beeswax cylinders. They're what we're interested in. We're not interested in the volume of the wooden crate. We're interested in the volume of these beeswax cylinders. So what it does tell us is that they have a length of 32 centimetres and that there's 8 cylinders in each row. So we can find the diameter, because if we do 48 divided by 8, that is 6 centimetres. So the diameter of each of these is 6 centimetres. So if that's the diameter, the radius of each of them would be half of that, which would be 3 centimetres. So 2 things we tend to need when we're working with circles. Okay, we need the volume, guys. So we want to see if his calculation around mass is correct or not. We have the density of each of these, but we need the volume. So let's work out the volume. This is of 1 cylinder, guys. Okay, so the volume of a cylinder is pi times radius squared times that length, guys. And we're told that they have a length of 32. So times by 32. So pi times our radius of 3 squared multiplied by 32. So pi times 3 squared times 32, which is 288 pi. That's for 1 cylinder. We need to figure out how many cylinders are going to fit in this crate, okay? So if they fit 8 across with diameters of 6 centimetres, the crate goes up 60 centimetres. So we need to see how many rows up. So we've got 8 across, how many rows up? So we're going to do 60 divided by 6. So 60 divided by the diameter of these, which gives us 10. So we have 8 across the bottom and 10 up the top. So 8 times 10 tells us we have 80 cylinders in total. Okay, so we have 80 cylinders in total. Now what we need to double check here first of all is that we work out the mass of 1 cylinder, and then we're going to multiply it by 80 to see, because we're working with the total mass. So for the mass of 1 cylinder, this is the volume of 1, this is the density of 1. So mass is density times volume. So the density is 0.961 and the volume is 288 pi. So times 0.961. So that's 869.4923155. So this is the mass of 1 in grams. Okay, we've got 80 in total, so let's multiply this by 80. So we're going to multiply it by 80. So we have 69,559.38524 grams. Now Jake's given his estimate in kilograms, so we're going to have to divide by 1,000. There are 1,000 grams in 1 kilogram. So when we divide by 1,000, we get 69.55938.524 kilograms. Let's compare this total mass with what Jake says. Jake says it's more than 70 kilograms. Well, actually 69.559 etc. is less than 70 kilograms. So Jake is not correct. Question 10. Max bought a new computer. In the first year, the value of Max's computer decreased by 19.8%. In the second year, the value of Max's computer decreased by 6.5% of its value at the end of the first year. Find the overall percentage decrease in the value of Max's computer at the end of the second year. You must show all your working out. Okay, so let's deal with the first year. So in the first year, it decreases by 19.8%. So it was 100% of the value, but then we take off 19.8% because it's decreased in value. It's got lower. So 100 take away 19.8 is 80.2%. Okay. I'm going to divide that by 100 to get it as a decimal multiplier because I like to work with those. So it's 0.802. Let's now deal with the second year. So in the second year, it decreases by 6.5%. So we'll have 100% of the value at the end of the first year, but we're decreasing by 6.5%. So we're taking that 6.5% off. 100 take away 6.5 tells me that that then becomes 93.5%. I want it to be a decimal multiplier, so I'm going to divide by 100. So that is 0.935. So for the overall percentage decrease, in the first year we would have multiplied by 0.802. And then in the second year we multiply by 0.935. So let's do that now. 0.802. So that is 0.74987. So that's the percentage of the computer's value that's left at the end of that second year. So we need to find the percentage decrease. So we're going to subtract that from 1, because 1 would be 100%. So 1 subtract 0.74987. 1 subtract our answer is 0.25013. So I'm going to multiply that by 100 to convert it into a decimal. So it's 25.013%. So the overall percentage decrease is 25.013%. I don't know why I called it a decimal then, guys. I do apologise. Question 11. Two groups of people, A and B. So we've got two groups of people, A and B, take part in a fun run. Everyone in the groups completes the run. The table gives a summary of the times, T minutes taken by Group A. So this is Group A's information. Part A, on the grid below, draw a box plot to represent this data. So to draw a box plot, we need the minimum, the maximum, the median, the lower quartile and the upper quartile. So we have most of those, we just don't have the upper quartile. But we have the interquartile range, so that will be helpful. So the first thing I'm going to do is I'm going to check the scale that I'm working with here. So from 13 to 14 is 1, but there are 5 little squares there. So each square, 1 divided by 5 is 0.2. So each square is worth 0.2. It's important to note when we're plotting these things on our box plot. So the first thing I'm going to draw is the minimum at 15.2. So that's 15, and then the 0.2 is there. So that's my minimum. Okay, I'm going to do my maximum at 23.2. So 23.2 is there. So I've done my minimum, I've done my maximum. I'm going to plot my lower quartile at 16.8. So that's 16.2468. And then I'm going to plot my median at 19.4. So 19.24. Keeping my lines roughly the same length. So the last thing I need to plot is my upper quartile. So the interquartile range is 4.2. So my upper quartile must be the lower quartile plus that 4.2, because that's the range between them. So 16.8 plus 4.2 is equal to 21. So I'm going to draw my upper quartile at 21. So my upper quartile and my lower quartile join to make my box part of the box plot, with the median in there somewhere. And then my maximum and minimum values are attached to that box using whiskers. Okay, so those end points, those extreme values. I used a pen there, guys. You need to use a pencil just in case you make mistakes. Okay, part B. The box plot below gives a summary of the times in T minutes taken by Group B. So this is not Group A now. That's Group A. This is Group B. Marcy makes 2 statements using information from the box plots. Are Marcy's statements correct? Explain how you decide. So her first statement, on average, runners in Group B ran faster than runners in Group A. Correct or not correct? Okay. So on average, they ran faster. So here we're dealing with the median, guys. Okay, when we're dealing with an average, we're dealing with median from a box plot. So the median, so Group A's median, they gave us as 19.4. And Group B's median, we're going to read that off. So we've got the same scale. Each little square is 0.2, so that's 18.246 is 18.8. So this is their medians. on average, runners in Group B ran faster than runners in Group A. That's true because Group A's got a smaller median, which is less time. Remember, this is time. So the smaller the time, the faster they are. Okay? So we can say she's correct because the median for Group B is lower. Remember, we've got to give an explanation of how we decide. Let's have a look at the other statement that she's mentioned. So here she's mentioned there's a greater proportion of runners who took less than 17 minutes in Group B. Okay, to a greater proportion. So less than 17 minutes. So we're working with the lower quartile here, guys. Okay, so less than 17 minutes. So if we look at the lower quartile for A, it's slightly less than 17, but the lower quartile for B is more than 17. So she's not correct. So we're going to say not correct because Group B, their lower quartile is more than 17. We're talking less than 17. So let's talk that. The lower quartile for B is more than 17. She said less than. But the lower quartile for A is less than 17. Question 12. The equation 2x cubed add x squared subtract 12 equal to 0 has a solution between 1 and 2. Use trial and improvement to find this solution correct to 1 decimal place. Okay, so we're going to start with the values 1 and 2, guys. Okay, so if the solution is between 1 and 2, when x is 1, so 2, 1 cubed, we're substituting in x, 1 wherever there's an x. So we're going to do 2, 1 cubed plus 1 squared minus 12 is equal to minus 9 when x equals 2. So we're substituting a 2 in. I'm going to go back an arrow through and just change that 1 to a 2. Is 8. So yes, there is a solution between 1 and 2 because we've got that sign change, but we need to figure out to 1 decimal place what that solution's going to be. Okay, so we're going to go in the middle of these two now. So when x equals 1.5. So we're going to arrow back. So this is -3. So we're getting closer to 0 here. So let's try 1.6. So this is a great thing about these calculators, guys. If you remember what it is that you are substituting, you can just go back and change it. So, right, okay. So I'm going to go in the middle of these two now. So let's go with x equals 1.55. Okay, let's go back here. So it's minus 2.14975. Okay, what about when x equals 1.7? Okay, so between 1.6 and 1.7, we go from -1 to 0 point something. So it's going to be between these two somewhere. I didn't really need to do that one. I don't know what my brain was doing. So I'm going to go with 1.65. So it's halfway between 1.6 and 1.7. So 1.65 cubed, 1.65 squared minus 12. Let's have a look. So we are getting closer here. Okay. So we've got 1.65. So between there. So let's go with 1.75. Okay, so we have a solution between 1.65 and 1.75, okay, because we still got that sign change here. So to 1 decimal place, so 1.65 to 1.7, to 1 decimal place 1.65 and 1.7 here, look. 1.7, 1.65, 0.7. So they're closest to 0. So we're looking for a solution to 1 decimal place. So I'm going to go with x equals 1.7 because 1.65 rounds to 1.7. And then when we get to 1.7, we've just gone past 0. So we could have 1.655. And that would gradually get us close to 0, but they would round to 1.7. So I'm going to put x equals 1.7 as my 1 decimal place. Question 13a. An architect measures the height of a wall. She uses a laser measuring device, so this device here. The measurement is 2,652 millimeters. Correct the nearest 1.5 millimeters. What is the lower bound of the height of the wall? Okay, if it's to the nearest 1.5 millimeters, we need to half 1.5. So 1.5 divided by 2 is 0.75. So the lower bound is this measurement subtract 0.75. So 2652 subtract the answer, which is 2651.25 millimeters, and that's our lower bound. If it wanted the upper bound, we would add that value, but it asked for the lower bound, so we subtract it. Part B. A builder measures the lengths of 2 pieces of wood. He uses a tape measure. The lengths are 2.85 meters and 1.90 meters, both correct to the nearest centimeter. Calculate the greatest total length of the 2 pieces of wood. Give your answer in meters. Okay, so these are in meters. Correct to the nearest centimetre, okay? So to the nearest centimetre, we are working in centimetres. So it would be easier to work in centimetres. To 2.85 metres is 285 centimetres. 1.90 metres is 190 centimetres. We multiply by 100, remember. To the nearest centimetre, so it's to the nearest 1 centimetre. So the upper bound would be half of that added on, so 285.5 centimetres for the upper bound. And then same again here, the upper bound would be 190.5 centimetres, so it's to the nearest centimetre. I'm working with the upper bounds here, guys, because I want the greatest total length, and I'm going to add them together, so I want the maximum values both could be. So we have 285.5 plus 190.5. So the maximum length they could be is 476 centimetres. We want our answer in metres, so let's convert that back. So divide by 100. So that's 4.76 metres. Question 14. Dora has 2 boxes, A and B. The boxes contain beads which are identical in shape. Box A contains 9 green, 6 red and 5 yellow. Box B contains 12 red and 8 yellow beads. Dora takes a bead at random from box A. If the bead is green, she puts it back in box A. If it's red or yellow, she puts it in box B. She then takes a bead at random from box B. Complete the tree diagram. Okay, so we need to be careful here, guys, because there's some tricky criteria that we need to meet here. So we have 9 plus 6 plus 5, okay? 9 plus 6 plus 5, I'm writing it down there because it's the only space I can find, is 20. So we have 20 beads in total in box A, so that's why we've got our probabilities out of 20. So we have 9 green, 9 out of 20 green, 6 out of 20 red, 5 out of 20 yellow. Okay, but we need to complete the rest of it. So this, if the bead is green, she puts it back in box A. If it's red or yellow, she puts it in box B. So box B has 12 plus 8. So it has 20 beads in there. So red is 12 out of 20 and yellow is 8 out of 20 to start off with, okay? So if she picks a green, that green goes back in box A, so it doesn't change anything to do with box B. So that would be 12 out of 20 and 8 out of 20 for red and yellow from box B. It's these two that make a difference. So if it's red or yellow, she puts it in box B. So she's picked a red out of box A, but she's putting it in box B, guys. So rather than there being 20 in box B, there are now 21. And there's an extra red because she's put it in box B, so that becomes 13. But there are still only 8 yellows. And then on this option, if she picks a yellow first, she puts it in box B again. So the totals are going to become 21 again. But this time the reds are going to stay as they are because it's a yellow that's been put into box B. And the yellows are going to increase by 1. Part B, find the probability that Dora takes 2 beads of the same colour. Okay, so there isn't a probability of taking a green because there are no greens in box B. So we're only dealing with red and yellow. So it's the probability of red multiplied by the probability of red and the probability of yellow multiplied by the probability of yellow. Remember, when we're moving across these branches, we multiply. So if I pick a red in the first instance, it's 6 out of 20. If I pick a red again, it's 13 over 21. If I pick a yellow in the first instance, it's 5 over 20. If I pick a yellow again, it's 9 over 21. I'm going to stick those fraction calculations into my calculator to make my life easier. So I'm going to multiply 6 over 20 by 13 over 21. So that's 13 over 70. Do the same with these. So 5 over 20 multiplied by 9 over 21, which is 3 over 28. And then I'm going to add these probabilities together. So 13 over 70 add 3 over 28. So I'm going to add 13 over 70, which is 41 over 140 is the probability that Dora takes 2 beads of the same colour. Question 15. In this question, all lengths are in metres. So everything's in metres. So we've got this rectilinear shape, this L shape. The diagram's not drawn to scale, so we can't measure anything directly from it. It's labelled with some of the lengths. The shape is made from 2 rectangles. The area of the shape is 10 metres squared. Part A, show that 3x squared add 2x subtract 1 equals 0. So we're working with area here, guys. Okay, so what I'm going to do is I'm going to try and find the area of this shape. What I'm going to do is I'm going to split the shape into 2. So I'm going to call that A and I'm going to call that B. So I'm going to work out the area of A to start off with. So the area of A is 2 multiplied by this length here, not 2x add 4, okay? And this length here is 2x add 4 subtract 2x, because that whole length there is 2x add 4, but that little 2x bit's been missed off. So 2x add 4 subtract 2x is just 4. So the area of A is 2 times 4, which is 8 metres squared. I'm now going to do the area of B. So the area of B is this rectangle here, and it's 3x plus 2 multiplied by 2x. So 2x multiplied by 3x plus 2. The brackets are important because that 2x gets multiplied by 3x and by 2. So when we expand that, 2x times 3x is 6x squared, and then 2x times positive 2 is positive 4x. So this total area is the area of A add the area of B. So the area of B is 6x squared plus 4x, and we're going to add the A, and we've been told that the area of the shape is equal to 10 metres squared. We're trying to show that it would also equal 3x squared add 2x subtract 1 equals 0. So I need this to be equal to 0 to start off with. So I'm going to subtract 10 from both sides. So when I subtract 10 from the right hand side, I get 0. When I subtract 10 from the left hand side, it's 8 subtract 10, which is negative 2. Now I'm going to compare this with this. It doesn't match. However, what you can spot is that 6x squared is double this, 4x is double 2x, and minus 2 is double minus 1. So we're going to divide everything by 2. So 3x squared plus 2x subtract 1 is equal to 0. So we've shown that that quadratic expression is true. Part B, calculate the value of the perimeter of this shape. You must show all your working out. So the perimeter is all the way around the outside of the shape, but we need the value, so we don't want any algebraic terms, okay? What we want are numbers all the way around. So we're going to have to solve for this variable x. So we're going to start by using this quadratic that we formed for the area. So 3x squared plus 2x subtract 1 is equal to 0. I'm going to solve for x, guys. I'm going to do this by factorising, okay? So when I factorise this equation, I want 2 brackets because I've got a squared term and a constant term. My only option inside those 2 brackets are 3x and x. So 3x times x give me 3x squared. 2 numbers that multiply to give me 1. Well, my only options are 1 and 1. But what I have to remember here is that one of them is going to get multiplied by 3 if this bracket expands. So this one is going to get multiplied by 3. I'm trying to make positive 2 when I add them together. So this is going to be my negative 1 and this is going to be my positive 1. Negative 1 multiplied by positive 1 is negative 1. 3 times 1 is 3. Subtract 1 is positive 2. So that's our factorised quadratic. We're now going to solve for x. So 3x subtract 1 equals 0 for that first bracket. 3x equals 1, so x equals 1/3. Let's try the other bracket. X plus 1 equals 0, so x equals negative 1. I'm going to discount that value because I can't have a negative dimension on a shape. We're working with a shape, so I'm going to go with the fact here that x is positive 1/3, okay? And I'm going to substitute it in wherever I've got an x. So to find the perimeter all the way around the outside, so we want to do 2x plus 3x plus 2 plus 2x plus 4 plus 2, and then remember we worked this out before, plus 4. So I'm going to collect like terms with that expression. Just let me get that out of the way. So we have 2x plus 3x plus 2x. So 2x plus 3x is 5x, plus 2x is 7x. So 7x, and then we have 2 plus 4 is 6, plus 2 is 8, plus 4 is 12. So 7x plus 12. We know that x equals 1/3. So 7 times 1/3 plus 12. So 7 times 1/3 plus 12. So that's 43/3, but I want to see what that is as a mixed number. So that's 14 and 1/3. Now what I've just noticed, guys, is I missed off one of the sides of this shape. So I need this part of the shape as well to find the perimeter. So this is 3x plus 2, subtract that 2. So 3x plus 2, subtract 2 leaves me with 3x. So I've also got to include 3x in here. That's an easy mistake to make, so don't make that, guys. So I'm going to do 14 1/3 plus that side of 3x. Well, I know that x is 1/3, so that's 14 1/3 plus 3 times 1/3. So plus 3 times 1/3, oh, go back, is 46 over 3, which if I press shift and the SD button is 15 1/3, and we're working in meters, don't forget, so that's our total perimeter. So just to note, the mistake I nearly made there, guys, was I forgot about this little part of the length here, so all the way around the outside for your perimeter. Question 16. So we've got a diagram here with vectors label. It's not drawn to scale, so we can't measure anything directly from it. So OABC is a parallelogram. OABC, so this larger shape is a parallelogram. OA equals A, so the journey from O to A is equal to bold A. And O to C, the journey from O to C is equal to C, and that's been labelled. D is the midpoint of AB, and E is the midpoint of OD. So AB, this is the midpoint. OD, this is the midpoint. Now this is a parallelogram, so what I'm going to do to start off with is label the parallel sides. So OA and CB are parallel, so I'm going to draw the arrow in the same direction and also label that as little a. And then OC and AB are parallel, so put the arrow in the same direction and also label that as little c. So part A, find OD in terms of A and C. So we're doing the journey from O to D, okay? But we can only follow a path that we know information for. So to get from O to D, we're going to go OA, so across here, and then we're going to go A to D. Okay, and that's what's going to tell us our vector OD. But we don't know A to D yet. But we know that D is the midpoint of AB. So if D is halfway and the full journey is C, then A to D must be a half C. So O to A is A to D is a half C. So that's our vector O to D. Part B, find O to E in terms of A and C. So we're finding this journey here, O to E. Remember, E is the midpoint of OD, so that's halfway across OD. So we're going from O to E. So O to E is half of OD. Well, we know OD is here, okay? So O to E is a half of OD. So O to E is a half of A plus a half C. So O to E is half times A, which is a half A, and then a half times half C, which is a quarter C. So that's our vector O to E. Part C, find C to E in terms of A and C. Give your answer in its simplest form. Okay, so we're looking for C to E, okay? So C to E, and we're going to have to go through journeys that we know. So we're starting at C, so we're going to go C to O, and then we're going to go O to E. Now, C to O, we're travelling in the opposite direction of the arrow. So this is the this is going to be the inverse sign, guys. So this is going to be negative C. So C to O is negative C. O to E, we worked out here. So it's negative C plus a half A plus a quarter C. So we need to simplify this by collecting like terms. So I've got a half A, positive a half A, but I've got to deal with minus 1C plus 1/4 c. So I've got -1 plus 1/4, which is -3/4 c. And that's our final vector for C to E. Question 17. So we've got a cuboid and it says the diagram is not drawn to scale, so we can't measure anything directly from it. The diagram shows a cuboid A, B, C, D, E, F, G, H. So this is our cuboid here. Calculate the length of the diagonal F. So we're trying to calculate the length of this diagonal here. So this is 3D Pythagoras, guys, okay? So this takes some visualizing, but bear with me. So what I can do here is if I join the diagonal DB, and then I'm going to highlight in orange this triangle. So FB hits the floor horizontally with DB, so that's flat on the floor. So this forms a right angle here, guys. So I have a right angle triangle, this being the longest side because it's opposite the right angle. I have the side 72, so if I find this side here, I can use Pythagoras to find DF, okay? What I've also got formed down at the bottom here on the base of the cuboid is another right angle triangle. So this is where you need to be able to picture these things. So that cuboid is flat on the floor, guys. So that means that this is also a right angle here. So I'm going to use this smaller green triangle to find the length DB using Pythagoras. And then once I have the length DB, I'm going to use the bigger triangle to find the length DF. So DB is equal to the square root of 33 squared plus 56 squared. Okay? So the square root of 33 squared plus 56 squared, which is 65 centimetres. So DB is 65 centimetres. So now I'm going to find DF. So DF using Pythagoras should be equal to the square root of these two sides squared added together. So 65 squared plus 72 squared is 97 centimetres. And that's our answer for DF. 18a, the diagram shows a sketch of the graph y equals f of x. So this is y equals f of x. Point A has coordinates -3, 0. Point B has coordinates -1, 1. Part 1, sketch the graph of y equals f of -x on the axes below. You must indicate coordinates of the new positions of point A and B. Okay, so the -x means we're changing the sign. It's inside the bracket, so it's the x coordinates that are changing. So because the x coordinates are changing, it's going to flip the graph over the y-axis. So this is actually a reflection in the y-axis. So for point A, the x coordinate is -3, the y coordinate is 0. The y coordinate is not changing, but the x coordinate, we're going to change the sign. So instead of it being -3, point A is going to be at +3. The y value staying the same, guys. Let's look at point B. So remember, the x value changes sign, the y value stays as it is. So as the x value is -1, it's going to become +1. So let's put that here. So x is +1, the y value stays the same, and then we just need to draw the graph reflected as best we can. It doesn't have to be perfect, just has to be as similar as possible with the correct new coordinates labelled. Part 2, sketch the graph of y equals f of x plus 2 on the axes below. You must indicate the coordinates of the new positions of the point A and B. So we're starting with this original graph again, but this time the change is happening to the y coordinates because it's outside of that bracket. So what's happening is we're adding 2 to the y coordinates, so it's going to shift everything up 2 places, sorry. So here the coordinate of A is -3, 0. X is going to stay at -3. But that 0 is going to move up 2. So A is going to go from here. It's going to go up 2 places. So A is -3, 2. B, the x coordinate is staying the same, but the y coordinate we're adding 2 to. So when we add 2, it's going to go up by 2 places. So the y coordinate becomes 1 plus 2, which is 3. But the x coordinate stays at -1. So x coordinate is at -1. So this is 2. So let's call that 3. So B is -1, 3. Don't forget the origin here. It's currently at 0, 0. But everything's shifting up 2 places. So the origin is going to move up to 0, 2. There. So we're going to draw that in as best as we can with those points labelled. And you can see then that this graph, everything has shifted up 2 places. Part B, the diagram shows the sketch of the circle with equation x squared plus y squared equals 289. Write down the coordinates of point C. So the equation of a circle is in the form x squared plus y squared equals the radius squared. C is on the circumference, so from the origin to C, that is the radius. So if r squared is equal to 289, then r, the radius, must be the square root of 289. So it equals 17. We want the coordinate of point C. So the x coordinate is 17, but the y coordinate is 0. So we're going to put 17, 0 as our coordinate. Question 19. So we've got a diagram here, not drawn to scale, so we can't measure anything directly from it. In the triangle ABC, so ABC, AB equals 7 centimetres, AC equals 9 centimetres, and the angle ABC equals 61 degrees. So ABC, 61 degrees. Find the angle BCD. So BCD. So this is the angle that we're looking for here, guys. Okay. So we're currently dealing with a non-right angle triangle. And we need to find this angle here. So what would be really helpful is if we knew this angle, because then these are angles on a straight line, and then we could calculate the angle that we're looking for. So we're looking for this one here, x. So what we're going to do here is we're going to use a sine rule to find this angle, because we have an angle on opposite side, an angle on opposite side in a non-right angle triangle. So when we're using the sine rule to find an angle, we flip it upside down. So sine of the angle BCA, we'll call it, the angle here, over 7 is equal to sine 61 over the opposite side, 9. So sine of the angle BCA is equal to 7 multiplied by sine 61 over 9. But we want the angle BCA, so we're going to do the inverse sine of this whole thing here. And I'm going to put it in my calculator. Just put that there to remind us it's an angle. Exactly as you can see there. So we have the inverse sine. So shift and sine. And then it's 7 multiplied. And then everything else is in a fraction. So it's sine 61. Close the brackets. Over 9. Arrow off the fraction. Complete the bracket. So that angle is 42.8639459. So BCA, that's this angle here. So we're going to subtract that now from 180 to find the angle that we're missing. So angle BCD is 180, subtract angle BCA. I'm writing it like that so I don't have to write this out, but I've kept it on my calculator to make life easier. So 180, subtract that answer, is 137.1360541. They haven't asked me to round it in any way, so I'm just going to leave it like that. So the angle BCD is 137.1360541 degrees. Question 20. So we have a diagram here, not drawn to scale, so we can't measure anything directly from it. The diagram shows a sector of a circle with centre 0 and radius 12. So this whole shape here is the sector. Angle AOB is 55 degrees. AOB, 55 degrees. Find the area of the shaded region. Okay, so to find the area of the shaded region, we need the area of the full sector, and then we need to take away the area of this triangle here. Okay, so let's do the area of the sector to start off with. So we do the angle we're given, theta over 360, because sector is a part of a circle and there are 360 degrees in a circle, and then we multiply that by the formula for the area of a circle. So let's substitute in what we know. Theta is the angle that we've got enclosed within that sector, so that's 55 over 360 multiplied by pi, multiplied by our radius squared, which is 12. It's also shown on the diagram there, so 12 squared. So let's put that in our calculator exactly as we can see it there. 55 over 360 multiplied by pi, multiplied by 12 squared. So that gives us 22 pi centimetres squared. So that's the area of the sector. Now we need to deal with the area of the triangle. Okay, so when we're working with the area of a triangle that's not a clear triangle that has a base and a height that we can multiply and divide by 2, we're using the trigonometric formula for area, so the sine rule for area. So area of the triangle, so this rule is a half AB sin C. So we're doing a half multiplied by AB, which are the radii that enclose this angle here. So remember, this is also a radius, so it's 12 centimetres. So it's a half 12 times sin of the angle that we're given. So that's 55. So I'm going to pop that in my calculator. So a half 12 times 12 times sin 55. So that's 58.97894719. So the area of the shaded region is the area of the full shape, the sector, subtract the triangle. So shaded region is 22 pi subtract this. I've kept that long decimal in there, so 22 pi subtract my answer is 10.1360919 centimetres squared. Again, they don't ask me to round it in any way, so I'm not going to. I'm just going to leave it like that. Part B, find the perimeter of the shaded region. Okay, so we want to find the perimeter of this shape here, guys. So we need to know this length, and then we need to know the arc length, and we need to add them together. So let's deal with the arc length first. So arc length. So the formula for the arc length of a sector is, again, the angle that we're given divided by 360, but this time multiplied by the formula for circumference, so pi times diameter. The angle inside is 55, so that's 55 over 360 multiplied by pi. Now the radius is 12. If the radius is 12, the diameter is double that, so that's 24. So multiplied by 24. So let's stick that in our calculator. 55 over 360 multiplied by pi multiplied by 24. So 11 over 3 pi. I'm just going to leave that in exact form for now. So that's the arc length. I now need to find the length AB. So I'm going to have to work with this triangle, and I've got two sides in the enclosed angle, so I'm going to use the cosine rule to find AB. So AB squared is equal to the two side lengths squared. So 12 squared plus 12 squared, subtract 2 times those side lengths. So 2 times 12 times 12 times cos of the angle, and the angle is 55. So what I'm going to do to start off with is just simplify this a little bit, so I have less to add into my calculator. So 12 squared plus 12 squared is 288. 2 times 12 times 12 is 288 cos 55. So this is what I'm going to stick in my calculator. So AB squared equals 288 subtract 288 cos 55. So that is 122.8099863. This is AB squared. I don't want AB squared, I just want AB. So I'm going to square root that answer. So we're going to square root this whole thing. So AB equals, now I didn't delete it off my calculator, so just square root of your answer. So that's 11.08196672. Doesn't say about rounding or anything yet, so that's also good. But we want the total perimeter, so we want the length AB plus the arc length. So we're going to do AB, so we're going to do AB plus the arc length of 11 over 3 pi, and I've put P there for perimeter. AB is still in my calculator, so I'm going to add the 11 over 3 pi to it, which gives me 22.60113978. Everything's in centimetres, so that's my perimeter in centimetres. Again, it doesn't tell me to round it, guys, so I'm not going to take the time to do that. Question 21. So we have the function g of x equals 2x squared, h of x equals x add 1 all over 4. Part A, show algebraically that the x coordinates of the point of intersection of the curve with the equation y equals g of x and the line with the equation y equals the inverse function of h of x are solutions to this equation. Okay, so first things first, y equals g of x is simply this function here. However, y equals the inverse function of h of x. So let's find that first. So I'm going to rearrange this. So I'm going to write it as y equals x plus 1 over 4. And then I'm going to rearrange it so that y is the subject. So the first thing I'm going to do is multiply both sides by 4. So that becomes 4y equals x plus 1. That's eliminated that fraction. Now I'm going to subtract 1 from both sides. So 4y subtract 1 is equal to x. Now I'm going to rewrite this with my inverse function notation. So x becomes my inverse function notation and y becomes x. So that's the first starting point. So now we're showing algebraically that the coordinates of the points of intersection of y equals g of x and y equals the inverse function of h of x are solutions to this equation. So points of intersection means we need to make these two equations for y equal to each other. So g of x equals 2x squared, which is equal to the inverse function of h of x, which is 4x subtract 1. Now I'm going to show that they have solutions to this equation, so I'm going to rearrange this to make it equal to 0. So I'm going to subtract 4x, so 2x squared subtract 4x equals negative 1. Remember, you're doing that from both sides. I'm now going to add 1, so 2x squared subtract 4x plus 1, and then when I add 1 here, that becomes 0. So now what we've shown is that this equation matches this equation, therefore they have the same solutions. Okay, part B, use an algebraic method to find the x coordinates of the points of intersection of the curve y equals g of x and the line y equals the inverse function of h of x. Give your answers to 2 decimal places. You must show all your working. So remember, we just said that the points of intersection have solutions to this equation. So this is the equation that we're going to start off with, this quadratic equation here from part A. Now it tells us that we need to give our answers correct to 2 decimal places. So I need to solve this quadratic equation, but the fact that I need my answer in 2 decimal places tells me that I can't factorise it. I'm not going to get integer values that would go inside brackets to make my life easy. So I either need to complete the square or use the quadratic formula. I'm going to use the quadratic formula. So x equals minus b plus or minus b squared minus 4ac square rooted, but that is all over 2a. So my a equals 2, my b equals minus 4, and my c equals 1. So minus b, so I change the sign of b. So x equals 4 plus or minus b squared minus 4 times a times c, all square rooted. So all I'm doing is substituting in my values for a, b and c. And this is all over 2a. So I'm going to stick that in my calculator now, guys, exactly as you can see it there. So I've got 4. I'm just going to put plus because I can't put plus and minus and get something nice to work with. So I'm going to put my square root. So I have got minus 4 squared. The brackets are important here, guys, just to make sure my calculator doesn't do anything stupid. So I've put everything in and I've pressed equals. So x equals 1.70710671, but I also need to put it in as a minus. So I'm going to go up, and instead of the plus here, instead of this plus, I'm going to change that to a minus. So x also equals 0.29289321888. So it wants my solutions to 2 decimal places. So I'm interested in 2 decimal places. So this 7 is going to change that to a 1. So that's 1.71. That 2 isn't going to change that 9. So that's 0.29. So they are my solutions to 2 decimal places. Question 22. The diagram shows the velocity v meters per second of a particle t seconds after it passes a fixed point. So we have our v meters per second is our vertical axis, and then our horizontal axis is our time. So this question's split across 2 pages, so you're going to have to just bear with me, guys. I apologise. I'll do my best to make sure you can see it all. So part A, calculate an estimate of the acceleration of the particle when t equals 3.5 seconds. So to do this, we need to draw a tangent at the curve at t equals 3.5 seconds. So we're going to go back to this graph. T equals 3.5, guys, is here, okay? So I'm going to go all the way up to my graph. T equals 3.5. So it's at this point here that I need to draw a tangent. So my tangent needs to follow roughly the curve of the line, guys. Okay, so roughly the curve that I could have probably twisted it this way a little bit, but there we go. And once we've done that, we work out the gradient of that line, because to work out acceleration, we want the gradient of this line. So this coordinate here that I marked there is at 32.5, is at 3.5 and 32.5. So I'm going to work with that, but then I'm also going to give myself another coordinate to work with. So here, so that's at 5.1 and 27.5. So I'm going to find the gradient. So I have 3.5 and 32.5, and then I have 5.1 and 27.5. So my gradient, guys, remember, move that out of the way in a second, is a change in y over the change in x. So my change in y, I'm going from 32.5 to 27.5. So I've gone down 5, and then I've gone from 3.5 to 5.1. So I've gone up 1.6. So I'm going to pop that in my calculator now. Negative 5 over 1.6 is equal to minus 3.125. Okay, so that's my estimate of acceleration. Can't speak. My estimate of acceleration based on my gradient, guys. Okay, so wherever you draw your tangent, as long as you've looked to draw a tangent at t equals 3.5, work out your gradient and you're going to get the marks there. Part B, use 5 vertical strips of equal width to estimate the distance travelled by the particle in the first 5 seconds after it passes the fixed point. So again, we're going to need to use our graph, guys, okay? So we want 5 vertical strips. So fortunately, 1, 2, 3, 4, 5. So I'm going to start by drawing those vertical strips just up to the curve. Look, guys. One, two, three, four, 5. But this is only an estimate, so now I'm going to make these into shape. So this is going to become a triangle. This, from this point to this point, is a trapezium. Here to here, also a trapezium. Here to here, also a trapezium. And then from this point to here is a triangle. So we've got A, B, C, D and E. So we're going to work out the area of each of these strips and then add them together to get an estimate for the distance travelled. Okay, so we're going to start by finding the area of A. A is a triangle, so we're going to do the base multiplied by the height and then we're going to half it. So the base is 1. The height goes all the way up to here, look, so it goes all the way up to 15. So the area of A is the base times the height divided by 2. So 1 times 15 divided by 2, which is 7.5. So that's A. I should make that nice and clear really, shouldn't I? Let's do the same for the area of B. So B is a trapezium, guys. Okay, so we're going to do our parallel sides added together. So this side is 15, this side is 35. So 15 plus 35. Remember, we've got a calculator, so I might as well use it. I sometimes forget. So that's 50. But then we multiply it by the height between them. Well, the distance between them is 1. So 50 multiplied by 1 is 50. And then we half it because it's a trapezium. So we're going to divide that by 2. So that is 25. Let's do the area of C now. So C is also a trapezium. So we've got 35 and then we've got 31, 32. So we're going to do 35 plus 32 times it by the height, the distance between them. Well, for all of these it's 1. So times it by 1 and then half it. Okay, now find the area of D. D is also a trapezium. So this we said was 32 and this side, the other parallel side, is 25. So we're going to do 32 plus 25, which is 57, times it by the height, which is just 1, and then half it, which is 28.5. One more strip to go, guys. So we're working with E. So we're doing the area of E, and E is a triangle. So we have a base of 1 and we have a height of 25. So we're going to do base times height divided by 2. So 25 divided by 2 is 12.5. So we've got the area of all 5 of those strips. So to estimate the distance travelled, we need to add all of those areas together. So 7.5, 33.5, 25, 28.5 and 12.5. So 7.5 plus 25 plus 33.5 plus 12.5 plus 28.5. Let's be careful when we add these in. So 7.5 plus 25 plus 33.5 plus 12.5 plus 28.5. So that is a total of 107. So our estimate for the distance travelled is 107 metres, guys. So 107 metres to finish that question off.